Alrighty, today we are talking about chapter 3.7. We're making our way through chapter 3. We're more than halfway there. And today we're talking about estimating decimal sums and differences. Okay, and your learning goal for today is to be able to estimate, to make reasonable estimates of decimal sums and differences. Why, in real life, do we need to estimate? What is estimating good for? Why do we bother talking about how to estimate? Clarissa?
Because when you go to the store, it's good to round up because it also includes tax and stuff.
Okay, so when we go buy things, sometimes we round to a higher number. If something costs $3.69, in our heads we might think, okay, that costs about $4, right? Because that'll make sure we have enough money, and also it'll compensate for things like tax, sales tax. Neha, why else do we like to estimate besides compensating for tax?
I guess when you need to add something quickly.
Yeah.
And if you don't have paper,
Mm-hmm.
you can just do it in your mind.
Sure. So estimating helps us add or subtract things quickly because it lets us do math in our heads, right? We don't carry pencils and papers everywhere we go, right? Very good. Okay, let's look at this problem. It says a singer is recording a CD. Okay, think of your favorite singer, whoever that may be. They're working on a new album. They're recording a new CD. The lengths of 3 songs are 3.4 minutes, 2.7 minutes, and 4.19 minutes. So there's 3 songs on this CD, okay? Are all songs exactly the same length in real life? No, right? Are they exactly 3 minutes and then the song ends? No, some are a little bit longer, some are a little bit shorter. So imagine you're a singer, he or she is making a new CD with 3 songs. The first song is 3.4 minutes, the second song is 2.78 minutes, and the last song is 4.19 minutes. Okay? The question is asking about how much time, ooh, careful there, Miss O, about how much recording time will be on the CD. Do you see words? Do you see a math question? What's the first thing we need to do? Zara? Yeah, what is the problem asking here?
About how much recording time will be on the CD.
Yeah, the question's asking about how much time will be on the CD. Okay? What's the important information we need to know to solve this problem? Liam?
The length of each song?
Sure. So the first song is 3.4 minutes, the second song is 2.78 minutes, and the last song is 4.19 minutes. Is there any other important information we need to know, Adriana?
They're going to be made into one CD.
Do we need to know that they're going to be on a CD?
But they're not going to be separate.
Oh, they're going to be combined together, okay, onto one CD. But there's one other, just even one word that's super important. Ariel? Oh, why is the word about really, really, really important, Jason?
Because you're not finding the exact answer you're estimating.
Yeah, it tells us that we do not need to find the exact answer, we just need to estimate. So what we can do is we can use rounding to estimate, okay? We can round each song length to the nearest whole number because we don't really care about the 0.4 or the 0.78. So let's see, 3.4. If we're rounding to the nearest whole number, which place value are we rounding to? If we're rounding to the nearest whole number, which place value are we rounding to? Misaki? The 3's place? The 1's place, yeah. So let's see, 3.4 rounded to the nearest 1, so we look at the tenths. Does that go up or down or stay the same? Stay the same, right? Very good. What about 2 7/8 hundredths? We're rounding to the 1's place still, so let's look at the tenths place. Is that 4 or less or 5 and above? 5 and above. So I need to give the 1's place a shove. So what's 2 7/8 hundredths rounded to the nearest 1? Show me with your fingers. Yeah, it's 3. Okay. What about 4 19 hundredths? What should that round to if we're rounding to the nearest whole number? Yeah, I see lots of you saying 4. Very good. So then we can just add 3 plus 3 plus 4. Is that something we can do in our head? What's 3 plus 3 plus 4? 10. So there will be about 10 minutes of recording time on the CD. Another way to estimate, besides rounding to the nearest whole number or to the nearest tens, is to use benchmark numbers. Raise your quiet hand if you've heard the word benchmark before. Yeah. Benchmark numbers are familiar numbers, numbers that we like to work with in our head. Sometimes we call them round numbers like 10, 100, 25. They're numbers that we know a lot about and that we can work with very easily in our heads. Okay? So benchmarks are familiar numbers that are used as points of reference. You can use the benchmark 0, 0, or 25 hundredths, 5 tenths, and 75 hundredths, and 1 to estimate decimal sums and numbers. My question to you, first of all, is what is the fraction form of these benchmark numbers, right? Because we know numbers can be written in decimals and in fractions. So here are the benchmark numbers. How do we write these in decimal forms? How do we write 0 in fraction form? Sorry. How do we write 0 in fraction form? Colin? Actually, it's just 0. 0 is 0. What about 25 hundredths? What do we know about 25 cents? If you have 25 cents, how much money do you have compared to $1? Adam?
You have a quarter of a dollar.
Yeah, that's why 25 cents is called a quarter, right? A quarter is worth 25 cents because that's 1/4 of a dollar. What about 50 cents? If you have 50 cents, how much of a dollar do you have? Soham? You have half of a dollar. And then if you have 75 cents, how much of a dollar do you have? How much of a dollar do you have? Rashika? Yeah, you have 3/4 of a dollar. And if you have $1, you have 1 out of $1. So we know these are, do you guys see how these are easy numbers to work with? We like these numbers, right? We can think about them very easily in our heads. So that helps us when we estimate with decimals. All right, here you see a number line. And on the number line you see it goes from 0 to our first benchmark number of 25 hundredths, to our next benchmark number of 5 tenths, to 75 hundredths, to 1. There's little tick marks along the way. Looking at this this number line right now, I want you to figure out what is the increment from here to here. Like what would I label this tick mark? If from here to here is from 0 to 0.25. What would this be? And what would this be? And what would this be? What would this be? Go ahead and write it into your notebook. We were trying to figure out how to use benchmarks to estimate 18 hundredths plus 43 hundredths. Go ahead and write that problem into your notebook as well. Did we figure out what the increment is? What would I label this right here? What would I label that right there? Jason?
0.05.
0.05. So each time I'm moving along one tick mark in the number line, I'm moving 5 hundredths. Here would be 0.1, 0.15, 0.2, and 0.25, right? We all good about that? Very good. So then what we can do is we can locate the location of both of these addends on the number line. The book has done for you already 0.18, right? They said that's about right here. Would you guys agree? Now find where you would place 0.43, 43 hundredths. Where might you put that on your number line? Go ahead and draw and mark it. It says 4, but not very neatly. Very good. Okay, so you can see now that we found both of the addends, we can think to ourselves, 0.18 is between 0 and 0.25. Would you agree?
Yeah.
But which one is it closer to? Is it closer to 0 or 0.25? Right? It's closer to this side, right? So it is closer to 0.25 or 25 hundredths. Let's look at 43 hundredths. It's between what two benchmark numbers? Okay, it's between 0.25 and 0.5. Right? Would you agree? It's between these two benchmarks? But which benchmark is it closer to? 0.25 or 0.5? 0.50. Okay. So then we can estimate that 18 hundredths is about 25 hundredths, and 43 hundredths is about how many hundredths? 50 or 5 tenths. Can we do 0.25 plus 0.5 in our heads? What does that equal? 75 hundredths. So we know, because we used our benchmark numbers, that 18 hundredths plus 43 hundredths is about 75 hundredths. And in fraction form, we would call that or 3/4. Very good. Okay.